All right, hello everybody. Welcome again to another issue. How about another episode of Algebra 2? We're in Chapter 3, Section 1 again. And for me, again. I'm hoping that this time this works. Had a little problem with the last video, as you know. So anyway, we're going to talk about elimination today, which is, again, remember, just another method of solving systems of equations. Okay, so we graphed them and saw where they crossed, and remember where they crossed. If they crossed in one point, that was the solution, or else they could be parallel lines, which would be no solution. Or if they were the same line right on top of each other, that would be infinitely many. So we're going to have the same kind of answers with elimination, but I think you might find this to be a little bit better. I prefer this method usually. Sometimes I'll use substitution. All right, well, let's get started. First of all, our objective for today, we want to be able to solve systems of linear equations using elimination. Here are the steps. First of all, multiply one or both equations by a number to result in two equations that contain opposite terms. Basically, you're looking to get your two equations where one of the terms, like the x's or the y's, are opposite of each other, so that if you add them, they'll cancel out. You might not have to do this step. If it's already opposite of each other, you don't have to do this multiplying step. But if they're not already opposites, then you would have to do this. Second, you add the equations together, which cancels out one of the variables. Then you would solve what you've got left. And then the last thing is take that answer. If you found out what x equals, plug it back in to find y. Or if you found out what y equals, plug it back in to find x. Okay? All right, here's our first example. Basically, we just have a number of examples here today, and that'll be it. So let's take a look at this one first of all. We want to use elimination this time. And so remember, what I said before was we're looking for a variable that we can cancel out if I add them together. And so in this case, if I look at that, I go, well, hey, look, I've got a positive 4y, and I've got a negative 4y. So they're already opposites of each other, so if I add them together, they'll cancel out. So let's do that. And this is kind of just, this is just kind of like, elementary school when you add stuff together. So we're just going to add 3x plus 4x is 7x. 4y plus a negative 4y, they cancel. And then 2 plus 12 is 14. Just add down the columns. And then we solve what's left, divide by 7, so that we find that x equals 2. We go, yay! But you know what, James? I'm not done yet. That's right. Got to plug it back in and find out what y is. Remember how we did that before? Now, when we did that before, we had that one equation where we always would get y by itself or x by itself, and it was a nice, easy one to plug back in. Here with elimination, we don't have that. So go back to one of the two original ones and plug 2 in for x. And, what do you think would be easiest there, James? Do you want to do the first one or the second one? The first one? Good. Okay. Why'd you pick the first one? Because this was 2 and not 12. The numbers were a little smaller. Yeah, that's what I would have done too. All right, so here's what we've got. 3 times x, but we now know that x is 2. And then you've got 4y equals 2. So we just plug 2 in for x, and then we solve this. So we have 6 plus 4y minus 6. So 4y equals a negative 4 divided by 4. And we see that y equals a negative 1. And then just like before, we want to give our answer as an ordered pair. So x comes first, so we're going to say 2, comma, negative 1. That is our answer. All right, good? Next one, example 2. Now you look at this one and you say, whoop, you know what, I don't have anything there that's opposite of each other where I can add them and get them to cancel. Because you got a 2y and a y, they're definitely not opposites. And you go, well, x and x, well, if I added those together, I'd get 2x. So that won't really work either. But here's the thing, okay, so here's kind of like the next level. If you look at the two x's that you've got there, well, I can't add them, but I could subtract them, couldn't I? So you go, yeah, I could subtract them. That would get rid of it. And that will work just as well. Now, be careful when you subtract because it can get a little tricky. But basically, if you're subtracting, here's what's going to happen. You're going to subtract this whole second equation. Okay? So, again, just like before, we're going to just subtract down the columns here. So x minus x cancels. 2y minus y is 1y. A lot of times people forget this one here, that it's subtracting still, and then 10 minus 6 is 4. So that one worked out pretty well, but you have to remember to subtract both of these other ones here, okay? I'm going to come back and do this slightly different in a second and see if you like that better. Once we know that y is 4, we want to plug this back in to one of these equations. Caitlin, what do you think you'd like to do? Plug it into the second one? Okay, good. I would too. So you have x plus 4 equals 6, and then all we have to do is subtract 4. X equals 2. So how would we write this as an ordered pair? What do you think we would do there, Brandon? 2, 4. Notice that even though we solve the x second, remember when we write it, it goes first. So we go 2, 4. Now let me just mention one thing here, because sometimes you might forget about this subtraction. So what you can do is this. I'm just going to rewrite the problem here. You have same problem here. Remember, you know, when you're subtracting like this, when there's a minus in front of that parentheses, what number is really in front there? It's really a 1, right? So it's, in this case, a negative 1. So what you can do, it's kind of like distributing a negative 1. And if you do that, then you can turn it into an addition problem, which might be easier. And so if you do that, then what would happen is you would go through, you'd keep this top one the same, x plus 2y equals 10. Then down here you would have negative x. When you distribute the negative 1, then you're going to have minus y, and then distribute equals a negative 6. Then you can go ahead and add these like you normally would. These cancel. 2y minus y is y. 10 minus 6 is 4. See, you get the same thing, but you're a lot less likely to forget to subtract one of these second and third things here. So might be worthwhile to go ahead and distribute a negative there instead of treating it as subtraction. Might be a little easier. All right, example 3. All right, let's take a look at this one. Okay, so take a look at this. Let's see what can we multiply by to get something where we can get it to cross out. Okay, get a good look there. What do you think? You got something there, Logan? 2 on the bottom. All right. Why 2 on the bottom? Because when I distribute this 2 here, 2 times negative x is going to be a negative 2x. So here's what we've got now. We've got 2x plus 5y equals 3. Negative 2x plus 6y equals negative 14, it looks like. Now the 2x and the negative 2x can cancel. This is going to give me 11y. 3 and a negative 14 is negative 11. Divide by 11. Oops, it's a positive 11 there. Y equals a negative 1. Yay, am I done? Not yet. Plug it back in. So let's plug this one into the, yeah, I don't know. Either one. Let's do the bottom one. So I'm going to have negative x plus 3 times a negative 1 equals negative 7. Negative x minus 3 equals a negative 7 plus 3. So that means negative x equals a negative 4. And remember, we don't want to know what a negative x is. We want to know what a positive x is. And so just divide it by a negative 1, which switches the signs and gives you that x is a positive 4. And so we would say our answer would be positive 4, comma, negative 1. Okay, good? All right. Example 4. Ooh, now look at this one. You can't just multiply one equation by a number to make it to where it can cancel out, because there's nothing I can multiply 3 by to get 5 for the x's, and then here there's nothing I can multiply this 3 by to get that 5. So what we're going to have to do is multiply both equations by a number. Now, it can be a different number. It does not have to be the same number. It will be a different number on both equations. So what number, think about the top and the bottom, could we multiply by to get, let's say, both of these x's to be the same thing? If you can't think of anything else, one thing that will always work is always multiply by the opposite number here. So because 5, you go 5 times 3 is 15, and then down on the bottom here, 3 times 5 is 15. So that will always work. It may not be the smallest numbers, but it will always work. So here's what we'll do. Let's take the top one and multiply by 3, and the bottom one will go by 5. And if you take a look at this even just a little bit more, this is going to give me 15 and 15. And it'd be better to have 15 and a negative 15 so I could add them, because I like adding better. So I'm just going to, on the bottom one here, go times a negative 5. It's as simple as that. All right, let's multiply it out here. 3 times 5x, 15x. 3 times 3, 9y. And 3 times a negative 10 is negative 30. On the bottom, when you multiply here, that's going to give you a negative 15x. Multiply negative 5 times 5 is negative 25y. And then negative 5 times negative 6 is 30. Okay? So, now what's going to happen? We add these together. 15 and negative 15, they cancel. Then 9 and a negative 25, that's going to give me negative 16. Y. Equals 0. All right. Then we just continue on. Now, don't get freaked out by this 0. 0 is just a number, kind of like anything else. And so if you divide by negative 16, just keep following the same steps here. You see that 0 divided by anything is always 0. So y equals 0. Are we done? Not yet. So let's plug it back in. Where do you want to plug it in? What do you think? What do you think? How about the bottom one? So it's going to be 3x plus 5 times 0 equals negative 6. These cancel. 3x equals a negative 6. Divide by 3. And it looks like we get that x equals a negative 2. Our final answer there, negative 2, 0. And you can always check these two if you're, if you're a little unsure. Just remember, if you take this negative 2, 0 and you plug negative 2 in for x and 0 in for y, you'll find that it should equal in both equations. So if you put negative 2 in here on the top one, negative 2 times 5 is negative 10. 0 goes in for y, and it cancels, so negative 10 equals negative 10. That's true. And then on the bottom you put 0 in for y. Y times 5, or 5 times 0 cancels. And then negative 2 times 3 is negative 6. Those are the same thing as well. Negative 6 equals negative 6. So you know that this is the correct answer. Okay? One more, and then we'll be done. All right, take a look at this one. What do you think you want to do there? You want to try to get rid of the x's maybe? And if you do, you go, well, what could I multiply 2 by to get 6? 3. And again, if you're thinking ahead a little bit, not just 3, but negative 3, because then that's going to give me a negative 6, okay? So distribute there, that's going to give you a negative 6x minus 9y, and then equals a negative 15. And then the bottom one can stay the same, 6x plus 9y equals positive 15. Okay, now we're going to add these out. By the way, I don't know if I really mentioned this earlier, but when you do this method, the x's, the y's, the equal signs, the numbers all have to be lined up, straight up and down. So, you know, you can't have these mixed up in a different order. They all have, it doesn't have to be this order, but it does have to be in the same order for both of them. So, all right, when I add these, negative 6x and 6x cancel. Negative 9y and 9y, uh-oh, they cancel too. So what do I got left on this side? Everything canceled. I've got 0. Huh. Well, what happens over here? Negative, oh boy, look, that cancels too. So what do I have left on that side? 0. So does 0 equal 0? Yeah, it does. And so remember before when we had something like this, if the x's and y's all cancel out and what we have left equals, what do you think that's going to be? Infinitely many solutions. Okay, just like before. And by the way, too, I'm kind of drawing a little line here, so this is not part of the problem. This is totally separate, so don't get confused. But what if happens if you worked something out and you ended up with like 6 equals a negative 12? What do you think that's going to be? No solution. So just like before, it's kind of the same type of things. If the x's and y's all cancel out, what you've got left equals, it's infinitely many. If they do not equal, it's no solution, just like it was before. Okay, well, thanks for being here. I am sure hoping that this is going to work and you're going to see this video. If not, I don't know what to do. But thanks for being here. I will see you next time. Bye.